section 2.4, biconditional statements. We want to be able to write and understand biconditional statements and determine if they were true. Biconditional really means it's conditional two ways. So we were talking about conditional statements yesterday, and we know that conditional statements are if-then statements. Well, a biconditional also, the converse also works. Like switching also works both ways. So it's kind of an interesting thing. It works both ways. And so the definition of a biconditional statement is the conjunction, and conjunction was when we had an and logic statement. And that's what that little conjunction and is. So we've been practicing with those logic statements. What does it mean if you have an and statement?
Like it can only be conditional if both are true.
If both are true. It only is true if both parts are true. So when we look at this symbolic form, each piece has to be true for the whole conjunction to be true. So it's the conjunction of the conditional, oh, that's what I just said. That's so funny. The conditional and its converse. And remember, what is converse? Well, opposite means not. So, no, that's contrapositive. So converse, all we had to do was switch. Yeah, we had to switch. That was, the converse shoes help us switch back and forth real fast. So that's, the converse was here, Q then P. So symbolic form here, we have if P then Q, and the converse is Q then P. So all we have to do is consider whether each of those conditional statements is true. Now, this is a long thing to write. So it's the conditional statement and the converse. So to clean it up, because like I've said before, we math people are lazy. So we just create symbols so that we don't have to write as much, all right? So we would say P implies with a double arrow Q. And this double arrow basically says here, P implies the Q, so there's the arrow pointing to the Q, and then Q implies the P, so we go from Q and we go backwards, so there's the arrow that implies the Q. Do you see that? You see how it's P goes to the Q and then Q goes to the P. That's what the double arrow's telling us. It's, yeah, they're going back and forth, right? So we got to do it both ways. So that's what that double arrow says. Are we true P to Q and also Q to P? All right, it's read as, so this double arrow is read as if. IFF is the abbreviation. It's read as P if and only if Q. P if and only if Q. And again, there's that abbreviation if. It's if and only if. So P if and only if Q is how we would read that. All right, so a truth value. The biconditional statements are true when both the conditional, C-O-N-D-I-T-I-O-N-A-L, the conditional and the converse are true. The biconditional statements are true when both the conditional and the converse are true. So let's test this. Let's see how we write them. So the directions, we're given given the biconditional statement below. And we know it's biconditional because it says if and only if, okay. Given the biconditional statement below, write both the conditional and the converse. Determine the truth value of the biconditional. Explain why it is true or false. Say it again. Well, we're going to actually write it out longhand here. So what do you think the conditional, well, here's our statement. Two angles are supplementary if and only if the sum of their measures is 180 degrees. So to write a conditional, we need an if, comma, then. So how are we going to translate this statement so that it says if, comma, then?
If the sum of their measures is 180, then two angles are supplementary.
And again, just like yesterday, I want you to say this part first. I know.
No, that's conditional.
Did you start with supplementary or did you say 180? You started with the 180? Yeah.
So if two angles are supplementary.
There it is. Good, good. Good. So we're going to go ahead and read this with the first thing first. So we're going to say if two angles are supplementary, if two angles are supplementary, comma, then the sum of their measures is 180 degrees. If two angles are supplementary, then the sum of their measures is 180 degrees. Okay, now, Clayton, what's the converse?
If the angle measures 180 degrees, then the two angles are supplementary.
Okay, and I'm just going to add like one or two words there. So the converse, so here we have our conditional. Here's our P statement right here. Two angles are supplementary. And the Q statement is the sum of their measures is 180. I would say if the sum of their measures is 180, but the there is non-specific. So I'm going to change that to if the sum of two angles measures 180 degrees. So that's how I'm going to say that. If the sum of two angles measures 180 degrees, then the two angles are supplementary. All right. Okay. So if the sum of two angle measures is 180 degrees, I guess is 180 degrees. The sum is 180 degrees. That makes more sense there. Then the two angles are supplementary. Okay. First of all, is the conditional statement true? All right. Two angles are supplementary. That means their measures are 180 degrees. That conditional is a true thing. All right. Is the converse true? If the sum of two angles is 180 degrees, then the two angles are supplementary. Is that true? Yes. Okay. And if both parts are true, then tell me about the biconditional. Yeah. Biconditional. Biconditional is true because both conditional and converse are true. You can abbreviate that. I put cond and con. Conditional and converse are true. All right. Let's look at number 3. Number 3. X squared equals 25 if and only if. Again, what does if and only if tell me? This is a biconditional. All right, that if in there, if and only if, tells me I'm looking at a biconditional statement. If and only if x equals 5. All right, what is our conditional? And again, I want the first thing first. Good. If x squared equals 25, then x equals 5. If x squared equals 25, if something squared equals 25, then x equals 5. Yeah. True or false? That's true. Okay, that's true. because if I take the 5, 5 squared equals 25. That is a very true statement. Okay. Oh, that's not true. Oh my gosh. Sorry, I'm going to come back to that. We'll talk about that in just a second. All right. What is the converse? Yes. Then x squared equals 25. I did that backwards, of course. Here, x equals 5. And so if x equals 5, then if we take 5 and square it, does it equal 25? Okay, the converse is true for sure. But let's go back to the conditional for a second. Here's what we're starting with, that something squared equals 25. Is 5 the only thing that we can square to get 25? This is always a tough one. Mm-hmm. Yeah. Is that the only thing? What it could be? It can be a negative 5, yeah. It's a different thing. This is false because negative 5 quantity squared means negative 5 times negative 5. Does that also give us 25? No. Yeah.
Yeah, negative times negative equals negative.
Negative times negative equals positive. Right? Yeah. All right. Okay. So here we're just starting with one value. And so the difference here is we're solving an equation here. X squared, what number squared gives us 25? There's more than one number that gives us 25 when we square it. All right, it's 5 does, but so does negative 5. Okay, so that's a kind of a tricky one. That's why I like talking about this one. So tell me about the biconditional. Is the biconditional true or false? Yeah. Yeah, biconditional, B-I-C-O-N-D-I-T-I-O-N-A-L. Biconditional is false, since the conditional is false. All right, fantastic. Do you have a question on that? All right, let's turn the page. Mind your P's and Q's. So this is just sort of an organizer, a graphic organizer to help us remember what is what. This is going to be real useful come test day because we won't have done this stuff for quite a while. And so this will be a nice sheet to come back to look at. So directions on compound statements. Use the statements below to write the compound statements. What is a conjunction? Two things combined with what word? And, an and statement. So P and Q would be a conjunction. All right. And so what should I write for my conjunction statement?
Is vertical angles are congruent?
So it's not a conditional statement. Yep. So we're going to say vertical angles are congruent. And 15 is a prime number. Vertical angles are congruent, and 15 is a prime number. You see how I abbreviated? You're more than welcome to abbreviate. All right, vertical angles are congruent, and 15 is a prime number. Okay, an and statement. For an and statement, what must be true? Both things must be true in order for the conjunction to be true. So, are vertical angles congruent? Yes, all the time vertical angles are congruent. Is 15 a prime number? No, it is not. 15 is 5 times 3. That definitely is not prime. All right, so is our conjunction true or false? False. Okay, what's the disjunction? What word do we use for disjunction? Or, and we would write that P or Q with that upside down caret, I don't know what you call it. Oh well. So what are we going to write for our statement? Yeah, vertical angles are congruent, or 15 is a prime number. Vertical angles are congruent, or 15 is a prime number. Okay, so for a disjunction, how do we know if it's true or false? If one of them, only one needs to be true. So vertical angles are congruent, true or false? True all the time. 15 is a prime? False. All right. But our truth value for the disjunction is true, because at least one thing is true. Okay. So the disjunction is true. All right, conditional statements. Now we can put in the if and then. These are conditional statements. Use the statements below to write the conditional. So our conditional, what's the notation we can use? Arrow rather. P, arrow, Q. P implies Q is how we would read that. We can also say if P, then Q. That works as well, but P implies Q. So what are we going to write? If it is St. Patrick's Day, then, then it is March. Then it is March. That was my grandmother's birthday, St. Patrick's Day. Okay. If it is St. Patrick's Day, when does St. Patrick's Day happen? March 17th. March 17th. Then it is March. Is this true or false? True. Yep. Hello. Hi. I do. Okay. Bradley, can you go see Miss Russell? All right. Inverse. What does the inverse do to the conditional? Not. Yeah, inverse inverts the P and Q, and invert just means the opposite. So this is not, remember that's what that little squiggle means, not P and not Q. So what do we need to do to our P and Q? Put in some knots. If it is not St. Patrick's Day, then it is not March. So all we had to do was insert some knots. True or false? False. Why?
Because it can still be March.
Yeah, it could be March 1st. Okay, March 1st is not St. Patrick's Day, but it's still March. So that is definitely false. Okay, converse. What do we do for converse? Switch. Switch the Q and the P. So this would be Q implies P now. All right, so we want to write if what?
It is March.
Good. Perfect. If it is March, then it is St. Patrick's Day. If it is March, then it's St. Patrick's Day. True or false? False. Every day is not St. Patrick's Day in March. So we definitely, that's definitely false. All right, and then the contrapositive. What do we do for the contrapositive? Not Q and not P. Yeah, we take the converse and insert knots into that. You negate and switch the conditional statement. So not Q implies not P. So I'm just going to take my converse and then insert some nots. So if it is not March, then it is not, oh, I forgot to change color. Then it is not St. Patrick's Day. That is true. That is true. If it's not March, so we're like February, January, any other time, then it's certainly also not St. Patrick's Day. So that is true. Okay, cool. Biconditional. The biconditional is P double arrow Q. So P implies, or P if and only if Q. So that's the double arrow's got to go both ways. And we want that if and only if statement in there to write the biconditional. So what are we going to write for our, it is St. Patrick's Day if and only if it is March. It is St. Patrick's Day if and only if it is March. So how do we know if biconditionals are true? If both the conditional and the converse are true. So the conditional was true, but the converse was false. So tell me about the biconditional. False. And it's false because the converse is false. All right. If both the converse and conditional were true, then it would be a true biconditional. Okay. Yeah, converse and conditional have to be true. Maybe we should write that down. Biconditional. Conditional and converse must be true. Conditional and converse must be true for a biconditional. All right, very good. Do you have questions for me? So that's all we're doing today, just sort of writing all these statements out.